hour. Today's topic is chapter 6, systems of linear equations, solving them. Okay, this is the topic that I'm going to cover today. First of all, the first systems of two linear equations in two variables. This is from section 6.1, and then larger systems from section 6.2, and application problems with three variables in section 6.3. So this covers what we covered this week. Okay, now the first thing we're going to cover is solutions of systems of linear equations. Number one and number two. Determine whether the given order list of numbers is a solution of the system of equations. Okay, now in order for this to, for the solution, we have to plug in -1 for x and 3 for y on both equations. So I'm going to call it equations 1 and 2. Let's go to number one first. I'm going to plug in -1 for x and 3 for y. And then we evaluate. So we get on the left side, we get 1 equals to 1. So I know this is true, right? So then now we can proceed to equation 2. It has to be true for both equations. For example, if it wasn't true here, guys, for number one on equation 1, then we will stop. Then that point is not a solution. But since this made it true, we continue to equation number 2. And again, we're going to plug in -1 for x and 3 for y. After we simplify or evaluate, we get 3 plus 6 on the left side. So 9 equals to 9, which matches the right side. That means that this point is a solution to the system. Now, number 2, we repeat the same process, but we have a different equation and a different point. So again, we repeat the process. We'll call equation 1 the first one and equation 2 the second one. So I'm going to plug in, let's see here, 2 for x and -0.5 for y. After we evaluate, we get 1 minus 4 on the left side, so -3 equals to -3. So then we can proceed to the second equation. We plug in 2 for x and -0.5 for y. But here, what happens, right? These are not the same because even though this is -0.5, it's not equal to -5. So this is not true. That means the point 2 -0.5 is not a solution to the system. Okay, so this is not true. So number 1 is yes, a solution, and number 2 is not a solution. And I believe this is the first part of section 6.1. Okay, now we're not graphing on this section here or this chapter. Okay, but the graphing method came from section 2.1, chapter 2. Okay, you can solve systems by graphing, by the substitution and the elimination method. Okay, for example, the picture here under A on the left, that means one solution. You see, this is what we're looking for where the two lines intersect. Figure B, this is infinite solutions because the two lines are the same. There's one on top of the other. And here's the example, -4x plus y equals 2 and 8x minus 2y equals to -4. These are the same line. So it's a line on top of a line. That means they're infinite solutions. And the index here, C, figure 1C, you will notice equation 1 or is in red and the other one's in blue. These two lines, they never intersect. That means these lines, there's no solution here, which means the lines are parallel. Okay, so let's recap. Figure A is one solution, figure B is infinite solution, and figure C is no solution. Okay, now, when you're solving by substitution or the elimination method, what does it look like towards the end when you're going to get the answer? Here it is. If it's one solution, you're going to get something like x equals to a or y equals to b. That means x equals to a number or y equals to a number. That means it's going to be one solution. That's like a hint there. Example, x equals 3, right, or y equals -2. If it's infinite solutions, you're going to get something like a equals to a. That means a number equals to a number, and if you notice, there's no x nor y in the equation. They both got eliminated, but the left side and the right side of the equal sign, they're equal. And most of the time, it's going to be something like 0 equals to 0. Okay? That means infinite solution. And lastly, on figure C, you're going to get something like A equals to B. And here, guys, I use the mathematical math language, right? A and B are real numbers, which means they can be any number. Example, 3 equals to 4, right? This is not true. That's why this one has no solution. And again, this one and B and C are almost similar because they don't have no variables, no x or y. Okay? Now, let me show you what I'm talking about one solution and two solutions and no solution. I'm going to do examples of each one. So then, this is called consistent and dependent system. Consistent dependent because this one depends on the x, and this is inconsistent. Now, solving by graphing, and again, this is not part of the section, but I want to cover it anyway. Just so you know that there's different ways to solve systems of equations. So I'm going to call that equation 1, right? If you recall, to graph this one in the y equals to mx plus b form, the m is my slope, which is a 3. And since the slope, right, you always put it as a fraction because you're going to put it as rise over run. So 3 is equivalent to 3 over 1, which means, right, and then the b is my y-intercept, and that's my starting point. So for 3 over 1, it means it's going to go up 3 and 1 to the right. From where? From my b, which is my y-intercept. So this is your starting point, 0, -6. Right? This here where the mouse is, this is my starting point. Then I'm going to go up 3, 1, 2, 3, and 1 to the right. Here's my point. And all we do is connect the dots with a line. Now let's go to equation number 2. Equation number 2, you can do it two ways. You can do it by finding the x and y intercept, or by putting it in the form y equals to mx plus b, which is called the slope intercept form. So I'm going to set it up this way. Right, so here I'm going to add 5x to both sides. So I get negative 2y equals to 5x minus 10. Now I'm going to divide both sides or everything by negative 2. So this is my slope, negative 5 over 2, which means it's going to go down 5 and 2 to the right. From where? From my b, which is the y-intercept. This is my starting point, 0, 5. So again, let's go here to the graph. 0, 5 is up here, right? Right there, where the dot is, 0, 5. Then I'm going to go down 5 because it's 5, negative 5 over 2. So I'm going to go down 5 from 0, 5. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. So now we connect the two points. So where do the lines intersect? They intersect at 2, 0. So that's my solution. My answer will be 2, 0. Okay, now I'm going to do this very same one. Do it by substitution. Okay. So now by substitution. So by substitution, you have to isolate one of the variables. In this case, equation 1 is already, the y is already isolated. All right, so I'm going to substitute the 3x minus 6 on equation 2 for the y. Right, because this is my y value, so I'm going to put it in here for the y. So I'm going to plug in 3x minus 6 for y. Now I get to distribute. So we got negative 5x minus 6x minus 6x plus 12 equals to negative 10. We can combine the like terms, which will give us what? Negative 11x plus 12 equals negative 10. Then we subtract 12 from both sides. The result will be negative 11x equals to negative 22. We divide both sides by 11, by negative 11. So the solution will be x equals 2. Right, but remember, the points where they intersect, it's a point. It's an ordered pair. You can have an x value and also a y value. So now we go back and substitute x equals 2 for either equation that's equation 1 or equation 2. Whatever is easier for you. In my opinion, equation 1 is easier. Why? Because the y is already isolated. So I'm going to plug in x equals 2 for the x. right? So this will give us 6. 6 minus 6 will give us 0. So what's my solution? X equals 2 and y equals 0. So it's going to give us 2, 0. That's my solution. You recall from the previous slide when we did it by graphing, we got the same thing. Okay? And again, when you have a solution, it's called consistent independent system. Now I'm going to do the very same one again, but do it by the elimination method. The elimination method, both equations must be in the form of ax plus by equals c. If you notice, equation 1 is not in the proper form, so I need to rewrite it in proper form. So here, guys, I'm going to subtract 3x from both sides. So now it's the proper form, right? So equation 1 is negative 3x plus y equals negative 6, and equation 2, we'll just bring it down. Now here is where students decide what's easier for them. But you have to eliminate either the x's or the y's. I believe I'm going to do it twice. I'm going to do it once by eliminating the y's, and then on the other side, I'm going to eliminate the x's. Just so you see the difference between both. Okay, now, if I'm going to eliminate the y's, right, this must be a 2 there for the y, because 2 minus 2y, 2y minus 2y will give us a 0y, right? They'll be eliminated. So I'm going to multiply the whole equation by 2. So we're going to multiply 2 times negative 3x, 2 times 2y, and 2 times negative 6. That's my result. Equation 2, we'll just bring it over. Now we get to add them. This is called the elimination method or the addition method. Okay? There's different authors that use different vocabulary for this. I mean, for doing it in this one. If you notice, right, the y's were eliminated. We got 11, negative 11x equals to negative 22. We divide both sides by negative 11, and we get x equals 2. Now we repeat the process, right? So x equals 2. So now we got to go back to either 1 or 2 and plug in the value for x and solve for y. In this case, right, it's still easier to plug it in equation number 1. So I'm going to plug in 2. So 6 minus 6 is 0. So my solution was 2, 0. See, we already got the same solution in 2 different ways. But now let's pretend that you don't want to do it this way. That you want to, instead of eliminate the y's, you want to get rid of the x's. Okay, so again, we do the same thing as the previous slide. Let's write it in proper form, just as we did before on the previous slide again. Right, so now let's say you want to get rid of the x's. You notice it's going to require more work because to eliminate, they're both negative. So one has to be a positive. So then that means that one I need to multiply by negative and the other by positive. So equation 1, I'm going to multiply by negative 5. By negative 5, because negative 5 times negative 3 will give us a positive 15x. And then equation 2, I'm going to multiply it by 3. Again, by 3 because it's going to give me a negative 15x. You see, guys, this will eliminate the x. If you notice, this one required an extra step because in the previous one, I only multiplied the first equation by 2. In this case, I need to multiply both equations by a number, which is a little bit more work. Now, the x's will be eliminated. So this will give us a negative 11y equals to 0. We divide both sides by negative 11, and the result will give us y equals to 0. Right now, we need to find the x value. So we're going to plug in 0 for y on either equation 1 or 2, whatever is easier for you. In my opinion, in this case, I'm going to plug it in equation number 2. But again, you can plug it in either one. So I'm going to plug in 0 for y. It will give us negative 5x equals to negative 10. Then we divide both sides by negative 5. And the result will give us x equals to 2. Again, that's the solution. You see, we did it 4 different ways, and we got the same solution. And this is also a consistent independent system. Okay, now Now, remember that I told you guys on the slide where we had, I think it was the second slide where we had the graph. Remember what one was infinite solution, one was no solution. Here's how they look like. Remember on the infinite solutions, at the end, you're going to get 0 equals to 0. Here's why. Okay, we're going to solve these by using the elimination method because it's easier. Okay, I want to get rid of the, if I want to get rid of the x's. So I'm going to multiply equation 1 by negative 2. If I do that, I have to multiply negative 2 times every term, or both sides of the equal sign. So negative 2 times 3x, negative 2 times negative 2y, and negative 2 times positive 4. And here's my result. So equation 2, how we do is bring it over. If you notice, everything on the left side will cancel, and also on the right side will cancel. So we got 0 equals to 0. Which means it's infinite solution. And this is called consistent dependent system. Now, remember the one that had no solution? Here's one that the result will be no solution. Plug in here. I'm going to eliminate the x's, right? So I'm going to multiply by negative 3, the first equation. So I'm going to multiply negative 3 times 2x, negative 3 times 5y, and negative 3 times 8. Here's my result. So equation 2, I'll just bring it over. Notice everything on the left will cancel. So negative 6 plus 6, x, negative 15y plus 15y will be 0 on the left side, but the right side will give us negative 6. You see, remember that there's no variables, no x or y, and this is not true because 0 does not equal to negative 6. That means no solution, which means the lines are parallel. This is called inconsistent system. Now, here's how you apply these type of problems in a word problem. Okay? Let's read it. A 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So what's my solution? What's my plan? So I need to find two equations. I'm going to do seats with seats and money with money. Okay? What does this mean? This I just made it up. So because at times students don't understand and they don't like these type of problems. So I try to make it as easy as possible for them. So I always say you're going to use people with people, money with money. In this case, it's going to be seats with seats. Okay? So since adults are first, I'm going to let that equal to x. Since the children are second, I'm going to let that equal to y because, or you can use a for adults and c for children. But I want to make it with x and y because that's the way they show solving systems of equations. So I want to use x and y. So this equation will be x number of adult seats plus y number of children seats equals to total of 200 seats. So it's going to give us x plus y equals to 200. That's my first equation. Now my second equation, I'm going to go money with money. So if adults, right, the tickets were $8 and x represents adults, so this will give us 8x. The children tickets are $5 and y represents children, right? So that's going to give us 5y. And the total income is 1,435. So that's my second equation. It's going to be 8x plus 5y equals to 1,435. So I got my two equations. Now you can do it any way you want by substitution, method, graphing, but I don't recommend graphing. And I believe the easiest way will be by the elimination method because it's already set up in that form. And that's the way I'm going to solve it. So again, we have equation 1 and 2, right? So here I'm going to get rid of the x's. So eliminate the x's. So I need to multiply equation 1 by negative 8. So negative 8 times x, negative 8 times y, and negative 8 times 200 will give us negative we have negative 8y plus 5y will give us a negative 3y, and negative 1600 plus 1435 will give us negative 165. We divide both sides by negative 3, and y equals to 55. So now I need to find x. So what's easier, 1 or 2? In my opinion, it's easier to go to number 1. So we know that y is 55. So I'm going to plug it in on the equation 55 for y. We subtract 55 from both sides, and the result is 145. So x is 145, y is 55, right? But that's not what they're asking for. They're asking how many adults and how many children were in the audience. Since x represents adults and y represents children, so this is my solution. 145 adults and 55 children. I believe this covers section 6.1. Now this one starts section 6.2. Now in systems of equations, with three equations and 3 variables. Okay, so I call it equation 1, 2, and 3. Hey guys, to solve it this method, it's always wise to rearrange them because we want to have the equation that has an x, coefficient of 1, be equation 1, because the work will be much easier. So if you have a system with 3 equations, you always want the one with a coefficient of 1 for the x, be equation 1. Okay, so let's rearrange it. I just switched equations 1 and 2. That's all I did. Okay, now. So what's the plan? At times in math, right? I always tell my students that it's always wise to come up with a solution, okay, or a plan. And this is a plan that I came up with, okay. And I believe I don't know if this is in the book because I've used this method for a long time and it always works. And if you follow this plan, you cannot go wrong. Okay. So there's a plan. I'm going to get equations 1 and equations 2, and I'm going to get equations 1 and 3. So here I'm going to eliminate the x's on both of them. Once I do that, I'm going to get a new equation 2 and a new equation 3. I believe in my notes I have equation 4 and 5, right? But just keep it new equation 2 and new equation 3 because this will help us when we do it by using matrix. Okay. Now I'm going to get my new equation 2 and my new equation 3, and I'm going to eliminate the y's. After you do that, this is what you should see. Z equals to C, and C can be any number, any real number. That's a plan. Okay. So now, after all the steps, it should look like something like this. You see, that's my first equation. On the second equation, you can use either or because you're going to get 2 equations, right? You're going to get either equations here, either or. And at the end, you're going to get equation 3. Then you're going to back substitute. Okay. Now, let's execute the plan here. Okay. I'm going to get equation 1 and equation 2. If you notice, because equation 1, right, because we rearrange it at the beginning, we rearrange it, it's easier to multiply something by equation 1 to eliminate the x's in equation 2. Right, so we're going to multiply equation 1 by negative 2. Again, why negative 2? Because we need for the x coefficient to be negative 2 in order to eliminate it. But we have to multiply negative 2 times every term or by both sides of the equal sign. If we multiply negative 2 times x, negative 3y, positive 3z, and 0, this is the result. Then equation 2 will just slide it over. And if you notice, the x's will be eliminated. So 6y minus 2y will give us 4y. Negative 4z plus z will give us negative 3z. And 0 plus 3 will give us 3. So this is my new equation 2. Now I repeat the process with equations 1 and 3. Now equation 1, I need to multiply by negative 3. So I have to execute the operation. This is my result. Negative 3x plus 9y minus 6z equals to 0. Equation 3, we just add it over. And if you notice again, the x's will be eliminated. So 9y plus y will give us 10y. Negative 6z minus z will give us negative 7z. And 0 plus 7 will give us 7. And that's my new equation number 3. Now I'm going to get my new equation 2 and my new equation 3 and eliminate the y. Okay, now here's where a lot of, here you can either do it two ways. Okay, the easy way will be to get the least common multiple, which is 20. But at times students don't even know how to do that. So that's why I tell my students because they're both positive correct, I need to multiply one by a negative. So equation 2, I'm going to multiply it by negative 10, and equation 3, I'm going to multiply it by 4. Right? So I multiply by the y coefficient, right, on equation 2, and then equation 3, I'm going to multiply it by the y coefficient on equation 2. But since they were both positive, one has to be negative in order for them to be eliminated. So I'm going to multiply equation 2 by negative 10. That's my result. I'm going to multiply equation 3 by 4. That's my result. You have to make sure that they get eliminated. Okay? So negative 40 plus 40 will give us 0. 30 minus 28, 30z minus 28z will give us a positive 2z. And negative 30 divided by negative 30 plus 28, will give us negative 2. And here, guys, we divide both sides by 2. So my z equals to negative 1. Now my z. Now, remember this is equation 1. Equation 2, I could have chosen the new 2 or the new 3, it doesn't matter. But I chose equation 2 because it's easier, the coefficients are smaller. And then we're going to back substitute. Okay, we're going to go now. We know the value for z now. I need to find the values for y and for x. So I'm going to go to equation 2 and solve for y. Right? We know z is negative 1, so I'm going to plug in negative 1 for the z. It will give us 4y plus 3 equals 3. We subtract 3 to both sides, and we get 4y equals to 0. We divide by 4, both sides. We got y equals to 0. Now we're going to go to equation 1. I have the values for y and z, right? Which is 0 and negative 1. So now I'm going to plug in the 0 for the y and the negative 1 for the z. After I evaluate them or simplify them, I get x minus 2 equals to 0. We're going to add 2 to both sides. So x equals to 2. I solved the system. The solution is 2 for the x, 0 for the y, and negative 1 for z. That's my solution. Okay, now, this is now the Gauss-Jordan elimination method. This method is a little bit challenging. I'm not going to lie to you guys. It's a little bit challenging. Every time that I cover this in class, I tell my students that, like in a funny way, I tell them, hey guys, you cannot blink, you cannot go to the restroom, you cannot look away, because if you do that, you're going to be lost. So I tell them that they have to concentrate on what I'm going to do and show them the board. Anyway, the system, the Gauss-Jordan elimination method, I kind of simplified it or modified it. So instead of using because I believe the book and most of other instructors and tutors, they use more than 6 matrices. They use like 6, 7, or 8 matrices to solve it. My modified method is only 3. But you have to simplify it as you go along. Let me show you first the objective and then the plan, and then we'll try to execute it. Okay? So here's the objective. You have linear systems of equations. You're gonna convert it to an augmenting matrix, and then you're gonna convert it to reduced low echelon form. That was the RREF stands for. Okay, here's a system. Okay, here's a system, right? How do we put it in an augmenting matrix? Right. This is our first row. second row, and third row. We're going to put only the coefficients. We got 1, -3, 2, and 0. That's row number 1. Row number 2 will be 2, -2, 1, and 3. And row number 3 will be 3, 1, -1, and 7. This is the augmented matrix. Now, I also show my students how to put it in the calculator for them to check their answer. Okay? But if you do that, or even if you do it by hand, this is the result that it should look like. Okay? This is what it means. This is the first column is the x's, the second column is the y's, and the third column is the z's. This means 1x plus 0y plus 0z equals to 2. In other words, x equals to 2. For row number 2, this means y equals to 0. And row number 3, it means z equals to -1. I believe this is the same matrix that I solved earlier, but we did it the other way. Now, so what's the plan? How can I go from linear system equation to the reduced row echelon form? Now, here's I call it the 3-step plan. Okay? Again, I'm going to use letters, right? So every letter is a real number. Okay, now this is the augmented matrix. I want to put it in this form. Right? This will be the value for x, y, and z. Now here's a plan. So so this is step 1. This is row 1, row 2, row 3. So step 1, the E and the I must be zeros. You see, all this is color coded. This is step 1 in blue. This is step 2 in green, and this is step 3 in red. Okay, so step 1, the E and the I must be eliminated. So I'm going to change. I'm going to use row 1 to change row 2 and to change row 3. After I execute the step, this will be my result. Again, if you notice, the first row stays how it is, but this will be different row numbers. But these two will be zeros. That's step 1. Step 2 is in green, right? So step 2 is in green means that these two must be zeros after I execute it. So row 1's got to change, and row 3's got to change. If you notice, because you're going to use row 2 stays the same. And this must be, after I execute it, these two will be zeros. It will be the second column on row 1 and the second column on row 3. Now step 3, I gotta change the U must be a 0 and the N must be a 0. So I gotta change row 1 and row 2. So after I execute the step here, right, and I push it simplify as possible as you're doing step, which I'm going to show you that what I'm talking about with a real problem. But this is my result, and you're done. Okay, now at times students get confused with all the letters because when I was in school, I used to get confused with all the letters. I was saying to myself, what are all these letters? If I already have enough with X and Y and Z, why do we use more letters? Okay, that's why I use a number sign, right? Number signs for numbers. Okay, I'm going to repeat the process real quick, right? But instead of letters, I use number signs. So this way, other students can follow. No one gets left behind. Okay, again, I went kind of quick, but instead of letters, I use number signs. Step 1 in blue, step 2 in green, and step 3 in red. And then we got, so whatever the number sign is here, right? So X equals to whatever is here, Y equals to whatever the number was there, and Z equals to whatever the number was there. Now, the 3-step plan in action. Okay, the same one as before, right? So this is what we want. Now, step 1. So I'm going to use the next 3 slides. This slide will show us step 1, the next slide will show us step 2, and then the first slide will show us step 3, and then we'll do another example and do it all in one slide. So this is row 1, right? This is row 2, this is row 3. So step 1, we're going to keep row 1. And the 2, where the 2 is on row 2, on the first column, that's going to be a 0. Which now I'm going to put it in blue. And also the third column, third row, that the 3 has to be a 0. So I gotta change row 2 and I gotta change row 3. That's why my arrow is in row 2 and also in row 3. Here we go. I'm gonna multiply row 1 by -2 to get rid of the 2 in row 2. It's gonna be -2 row 1 plus row 2. And then I'm gonna multiply negative 3 times row 1 and add it to row 3. And here on the bottom is my work. So -2 row 1 equals to -2, right? And this is row 1. 1, -3, 2, and 0. So I'm going to multiply, I'm going to distribute the -2. We get -2, 6, -4, and 0. There's row 2. So row 2, we just bring it over, right? And you notice the first column is going to be eliminated. We got 0, 4, -3, 3. This is my new row 2. Now I'm going to repeat the process for the second step and for the second part in step 1. Multiply -3 times row 1 will give us -3, 9, -6, and 0. When I add it to row 3, that's my result right then. I add them, it's going to give me 0, 10, -7, 7. That's my new row 3. Now the next step, I'm going to do it on the next slide. But I'm just going to bring this part over to the next slide. Okay, there it is. So now, and here's I'm also the color coded so we can follow it. Now step 2 is in green, right? So step 2 is in green, which means I'm going to eliminate the -3 on the second column on the first row and the 10 on the second column on the third row. So again, step 2, right? We can use row 2, so row 2 stays the same. We're going to eliminate the -3, so we're going to change row 1. We're going to eliminate the 10, so we're going to change row 3. Here we go. Since, right? So I'm going to use the 4 and the -3. So since one's already negative, one positive, so I don't need to multiply one by a negative. I'm going to multiply by the same sign. You can multiply by a positive. So I'm going to multiply 4 times row 1 and 3 times row 2. So it's going to be 3 row 2 plus 4 row 1. And here I'm going to multiply -10 times row 2 and 4 times row 3. And here's my work. 3 row 2 will be the same thing as 3 times row 2. Will give us 0, 12, -9, and 9. And 4 row 1 will be 4 times row 1, which is 1, -3, 2, and 0, right? So after we execute that, this is what we get. So now we're going to add them. We get 4, 0, -1, and 9. So this is my new row 1. Now, this is the second part, step 2. So -10 times row 2 will give us -10 and 0, 4, -3, and 3. And the result will give us 0, -4, -40, 30, and -30. Plus 4 row 3, you're going to multiply 4 times 0, 10, -7. So that will give us 0, 40, -28, and 28. So after I execute the operation, it's going to be 0, 0, 2, 2. Here's what I mean to simplify if possible without getting a fraction. So here, guys, this one here, row 3 becomes 0, 0, 1, -1 because I divided every term by 2. I simplify. And this will guarantee to have at most 4 matrices. So most of the time, it will only be 3 matrices instead of 6, 7, or 8, like the book does, and also other stuff in the tutor. So this is my new row 3. Now I'm going to finish it off on the next slide. Okay, I'm doing that. Now comes step 3, right? Step 3 is in red. So step 3 means that row 3 stays the same. The -1 must be a 0, which means I'm going to change row 1. And the -3 on row 2, column 3, must be a 0. That's why it's in red, so I got to change row 2. Again, recap. Step 1, we use row 1, and row 1 stays the same. Step 2, we use row 2, and row 2 stays the same. Step 3, we use row 3, and row 3 stays the same. So if you notice, I can eliminate the negative 1. I can just add them because negative 1 plus 1 will give me a 0. So it's going to be row 3 plus row 1. Here, to eliminate the negative 3 on the second row, third column, this must be a positive 3, which means I need to multiply 3 times row 3 and add it to row 2. And here's my work. Row 3 plus row 1 will give us 4008. Again, we simplify as we go along. We divide everything by 4. It's going to give us 1002, and that's my new row 1. So for the second part in step 3, we multiply 3 times row 3, which will give us 003, negative 3. We're going to add it to row 2. Row 2 is going to be 0400, so we divide everything by 4. So it's going to give us 0100 will be my new row 2. You notice we completed right because all these must be 1s and there are zeros, so x is my result. The solution, x equals to 2, y equals to 0, and z equals to -1. That's the three-step plan in action. Okay? Now, let's do one together. Okay? So again, the 1, we got to eliminate the 2 and the negative 1 right on the first column, which is row 2 and row 3. So we're going to keep row 1. We have to eliminate the 2 and row 2, so that's going to change. And we got the negative 1 must be a 0 in row 3, so row 3 is going to change. So I'm going to multiply negative 2 times row 1 and add it to row 2. Then for the second step, for the second part in step 1, I'm going to add row 1 plus row 3. And here's my work. So negative 1, right? So negative 2 row 1 plus negative 2 row 1 plus row 2 will give us negative 2, negative 4, 2, and negative 12. And we multiply negative 2 times row 1. We're going to add it to row 2. So all we do is bring it over. This is row 2, the 2, negative 1, 3, 2. We add them. That's our result. You notice, right? We can divide everything by negative 5 because it's always good to reduce. This way you eliminate the real big numbers. This will give us, simplify, 0, 1, negative 1, and 2. Because if I divide everything by negative 5, this is my result. So this is my new row 2. Now, for the second part, in step 1, we can add row 1 and row 3. That's row 1, that's row 3. So if we add them, this is my result. That's my new row 3. Now comes step 2. Put it in green again. So step 2, we're going to keep row 2. And the 2 and row 1, column 2 is going to change. So we're going to change row 1 and we're going to change row 3. So I'm going to use the row 2 right. So check this out. So this one is the one I'm going to use. That one there on the second row, second column. So to eliminate the 2 on row 1, I'm going to multiply row 2 by negative 2 and add it to row 1. And if we notice, right, these two are positive. So to eliminate the 1 on row 3, column 2, I need to multiply negative 1 times row 2 and add it to row 3. That works. Negative 2 row 2 plus, right, negative 2 row 2 will give us 0, negative 2, 2, and negative 4. And we add it to row 1. So we do row 1 over. So this will give us 1, 0, 1, 2. That's my new equation number 1. So I'm going to multiply negative 1 times row 2 will give us 0, negative 1, 1, and negative 2, and add it to row 3. And this is my result. Right? So I'm done with step 2. Now step 3. By step 3, I'm going to keep row 3. I gotta make the one, the first row, third column, that one, and I need to change that, right? That's gonna be a zero, so that's gonna change. And also the second row, third column, where the negative one is, that's gonna change. That's gonna be a zero, so that's gonna change. And we're gonna be using row one. So if you notice, to eliminate the one there on row one with the one from row three, I'm gonna multiply negative one and row three and add it to row one. If you notice, the third column, second row is a negative one, right? So I'm going to use this one on row three to make that a zero. If we just add them, that will eliminate the negative one on row two, column two. We'll just add them. So negative one, row three, right, will give us 0, 0, negative 1, 1, and add it to row one, and that's my result. 1, 0, 0, 3. Now, for the second part, in step 2, we just add row 3 plus row 2, and this is my result. 0, 1, 0, 1. You notice all these are ones diagonals, and the rest are zeros. That means that x equals to 3, y equals to 1, and z equals to negative 1. That's my solution. Okay, now, I believe this is the last problem that I'm going to cover. This is something from section 6.3. Okay, now, we need to find three equations. People with people, money with money, and the last, the second to the last sentence will be equation 3. So now, let's see here. People with people, right? So we have adults, we have teenagers, we have preteens. So I'm going to let adults be X, Y for teenagers, and Z for preteens. And there's 570, right? Again, people with people. So it's going to be X plus Y plus Z equals to 570. That's equation number 1. Now, equation number 2. Right? We know that adult tickets are $5, and since X represents adults, it's going to be 5X. We know that teenager ticket is $3, and teenagers Y represents teenagers, so that's going to be 3Y. And preteens, right? Preteens are $2, and since Z represents preteens, that's going to be 2Z. And the total money, right, was $19.50. So this is equation 2. 5X plus 3Y plus 2Z equals to 19.50. So I got two equations now, right? But I'm missing the third one. So here's where you find the second to the last sentence, where you find equation 3. Okay? This is right, they're talking about teenagers and preteens. So this is equation 3. But check this out. At times, it's very difficult by the wording to know it's like this, right? It's y equals to 3, 4z. So I tell my students, if it is difficult for you, you write it how it sounds and then flip it. Maybe the word flip it is a wrong term to use, okay? But let me show you what I'm talking about here. Doesn't it sound like 3/4 teenagers or 3/4 Y? Because my Y, right, is teenager, so I write it how it sounds. 3/4 Y equals to preteen. And then by the word flip it, and again, maybe that's a wrong word to use or the wrong vocabulary. You flip it, you put the 3/4 to the Z, and that's the setup. Maybe I can use a different word than flip it, right? Because flip it means that you switch the numerator with the denominator. Maybe I can just say you put the fraction on the other side or something like that. Maybe for next time. This is my setup. Okay, but now since we don't want to use fraction, right? Because most people are square fraction, most students. That's from experience. So to eliminate the fraction, I multiply both sides by 4. That will give us 4y equals to 3z, right? But the x, y, and z have to be on the left side, so we subtract 3z to both sides. That's equation number 3. Now, right now you get to try it. But I did it here anyway. These are my answers. Okay? Anyway, let's go back and try it. But we're not going to try it by using the Gauss-Jordan method because that would take us about an hour, right? So we can solve it by the way I explained at the beginning of the section of the PowerPoint where I said it was section 6.2. Okay, remember that we're going to get equations 1 and 2, get rid of the x's, and then also 1 and 3. So this is going to be doing. We're going to multiply -5 times equation 1. A result. Then I'm going to add it to equation 2. So this will be my new equation 2. Then, if you notice on equation 3, right, there's no x term, so I don't have to do that step because there's no x there's no x value on equation 3. We can skip that part. So this the equation 3 becomes my new equation 3. Now I'm going to get rid of the y's, right? So the first equation 2 I need to multiply by 2 because 2 times -2 will give us -4. Therefore, we add it to 4. That'll be eliminated. Okay, so they will give us what? -9b equals to -1800. We divide both sides by -9 equals to 200. Now I'm going to get three equations, right? I'm going to use the first equation. Then I'm going to use the equation that we got here, the new equation 2, and then the 200. Now I'm going to back substitute. So I'm going to plug in 200 for z. Then we're going to add 200. I'm going to add 600 to both sides. So give us -2 y equals to -200. We divide both sides by -2. The result is 150. Then I'm going to solve for x, right? So I already have the values for y and z, so all we do is plug it in. My y is 150, my z is 200. So 150 plus 1 will give us 350. We subtract 350 to both sides, and x equals to 220. So this is my solution here. 220 adults, and teenagers, and 20 okay, guys, well, I guess this is it for today's presentation. I hope this will be helpful. Does anybody have any questions that I can answer for you? If not, I just want to thank you for coming to today's Friday Night Happy Hour. And let me go back to the host.
Thank you, Mr. Isasi, for this amazing presentation. We learned a lot. And
Okay.
just remember from the next week, we're gonna have session from the next week because we is the holiday. But also remember from the April 5th, we have the math for math 13, 14 exponential and logarithm functions. And I'm sorry, properties of logarithms, exponents, and logarithms equations. And for math 1324, we have the basic metrics, operations, and inverse. Thank you to everyone to come to this amazing presentation and have a great weekend. Please let me know if you have any questions from the presentations. You don't have it?